Hi, this is Dan Swenson. In July of 2017, Kyle and I participated in the People Movement and Management Conference that was held in Derby, the UK. We went there because we wanted to expose Pathfinder to a new audience. Pathfinder was originally developed for emergency evacuation simulation as a companion product to PyroSim, our fire simulator. But we are adding features that will make it possible for Pathfinder to address more general people movement problems. I'm going to break my talk into two parts. In the first part, I'm going to talk about some of the basic concepts we use in Pathfinder. That will include the movement model, how we describe the space on which occupants walk, and how each person in the model is an agent that can make independent decisions. In the second part, I will give some examples of Pathfinder in action. The original movement studies were done by Fruin and published in 1971. He observed people in the Port Authority bus terminal and the Pennsylvania station in New York City. He measured walking speeds and observed levels of service. Gathering data continues today. Here is a video of merging at a T section measured by Seyfried and his collaborators. A primary result of the walking speed observations is the concept of a fundamental diagram that gives walking speed as a function of density. In this graph, the red curve is the original Fruin data, presenting speed as a function of the inverse of density, or square feet per person. The blue curve shows Fruin's data converted to speed as a function of density. And finally, the gray curve is the speed-density relationship used in the Society of Fire Protection Engineers Handbook. So we can see that the current SFPE regulations are directly dependent on the original Fruin data. We invest significant effort in documenting the performance of Pathfinder. Here is a validation problem that we use to verify that we are conforming to the desired speed-density relationship. This model simulates the Seyfried experiments, where density is controlled by using different sized entry and exit doors to a room. In the lower left, we have large entry doors and small exit doors, while in the upper right, we have small entry doors and large exit doors. We perform the calculation and then compare our results to the experimental data. In this figure, the blue and green dots are the experimental data, while the gray and black X's are the calculation. You can see a good correlation between calculation and experiment. Once we know the basic speed and density concepts we want to use for movement, how do we actually implement this? The first step is to create the movement mesh that defines the space on which occupants walk. We import a CAD model and then use our floor extraction tool. The geometric building blocks in Pathfinder include floors, rooms, doors, stairs, ramps, elevators, escalators, moving walkways, and exits. I want to emphasize the relative ease of creating a model in Pathfinder. Because the movement mesh is triangulated, Pathfinder can accurately represent geometric details and curves. Triangulation also enables fast algorithms for searching and pathfinding. In Pathfinder, each person is an agent. That is, each person calculates their movement, making their own decisions. Each agent has a profile. The profile describes the physical characteristics and decision-making preferences for that person. Each agent also has a behavior. The behavior defines the goals of the person. The behavior consists of actions, such as go to a room or wait for assistance. These can be organized in any logical order. Path planning is implemented using the locally quickest algorithm. The agent has knowledge of the time to exit the current room they are in and the time once they exit that room to the final goal. In the top figure, the shortest distance To the exit is the door to the right, but there is a queue at that door, so the occupant uses the door at the left. The inverse steering algorithm is used to avoid walls and other occupants while trying to remain on the chosen path. We have a debug mode that can show how the agent is making decisions. What we see here is an agent moving in the subway model. The path to an exit from the current room has already been calculated, and the agent is following that path. As the agent moves along, the rays extending from the agent show the directions where cost is being calculated for inverse steering. In this case, the agent is pushed from their original goal, which was the escalator, and uses the stairs instead. So this is the end of the introduction to Pathfinder concepts. The next video will show Pathfinder being used.